take a moment to pause the video to read through this full problem statement. And now that you've returned, what we're going to do is find several summary statistics for both depth and magnitude of these earthquakes. And if you have seen this problem already and clicked on the data table, you know there's a lot of data here. Actually 100 pieces of data for both depth and magnitude each. So one of the things that I would recommend doing is using technology. And also a little bit of a key here that this is a technology dependent problem, is because this problem label ends with the T. Okay, so I'm going to go back to the table, and over here this small icon, let's see, that says full data set. I can open up this data in StatCrunch. Now you saw there were some other options, but I want to show specifically StatCrunch because that's what this program is kind of made for, is for my math lab. So the next thing I'm going to do is select Stat, or just hover my mouse over Stat, and hover my mouse over Summary Statistics, and select Columns. Now I have two columns here, and I can select one at a time if I click on each independently, or if I hold down the Shift key, I can select both. I'm going to move down, and you can see already the following summary statistics are going to show up whenever I compute this program, or run this program. So some of these things I need, some I don't need. But one of them, when I tried this earlier, that I saw was missing was the population standard deviation. So if I come back to this list I can select from, I want to select this one, unadjusted standard deviation, by holding the Control key and then selecting that one item. Now notice what happened is I keep everything else, kind of your standard summary statistics, and now I've added unadjusted standard deviation, or in other words, population standard deviation. I'm going to choose to store this in a data table. That's kind of optional there. There's some different ways that it can output this information for you. And I'm going to select Compute. And move this out of the way. And now what I have is a table beside my data table with the summary statistics for depth all the way across this row and magnitude all the way across this row. Again, the only thing I noticed earlier that, like depth is the first one that you're asked for, I would not want to use this standard deviation because if I go back to the problem, it uses sigma, which is a shorthand for population standard deviation. So I'd rather put this one in. So I'm going to pause the video and input those values. All right, so see, I've typed in these values, rounded to 2 decimal places as I need to. Now I'm going to do the same thing for magnitude. So if I come back to StatCrunch and I find the row with magnitude, I'm going to write the mean, not this standard deviation, the median, the range, and the other values I needed there was Q1, Q3, and the population standard deviation. So I'm going to pause the video and put those values in. So you can see I put those values in here, rounded to 3 decimal places as needed. So up next, we're asked to make a conjecture about the shape of the distribution from depth. And we're given the following choices, where notice that all of these compare the mean to the median. And is it close? Is one larger or smaller than the other? And I just Googled a quick image for, I think I put in mean, median, and skewedness. So you have similar images in your text that show if the distribution is normal, then mean, median, and mode should be roughly the same thing. But if the distribution is skewed in either direction, notice that the mean is skewed towards the tail. Like in this case, skewed to the left, the mean's pulled to the left. It's less than the middle or median. Notice in this one that the mean is pulled to the right because the distribution has a tail to the right. Again, that tells us that the mean is more than the median. Also notice that that peak of the curve is the mode. It's neither the mean nor the median in those two cases of left and right skewed, or negative and positive skewed. So I'm going to come back to this question and looking specifically at depth values. So here were my depth values. And look how much larger that mean is than the median. So because that's the case, then we're looking at a distribution that has a shape like this, where the mean is much larger than the median. If I come back to my choices, the mean is much larger than the median. And notice another thing, if I go back, I can see that the mean is even greater than Q3. Let's go back and check. The mean is greater than Q3. So then the last part of this is deciding, do we call that skewed right or skewed left? And it's always skewed in the direction of the tail. So if it's shaped like this, the tail here is on the right, so that's going to be skewed right, is the best choice. And then the next question asks us something similar, but about the distribution for magnitude. So if I compare mean and median for the magnitude, these values right here, notice that the mean is larger than the median, but it is not larger than Q3. So let's just keep that in mind when we're looking at our choices. So the mean is larger than the median. We could say that's true. This right here says, and the distance from Q1 to M is less than the distance from M to Q3. So that's something else we would need to go back and check. So let's see here. Distance from Q1 to M. Q1 right here, 0.88 to M, is less than the distance from, I believe it said M to Q3, right? They're pretty close. I'm going to check on my calculator just to be sure. Actually, let's see. It does look like it is less. So if I just subtract 1.295 minus 0.88, I get that the distance between Q1 and the median is 0.415. And if I subtract the median and Q3, I get that the distance is 0.545. I mean, those are still pretty close. So let's see what other options that we have here. Again, we do know definitely the mean is larger than the median. And we just determined that the distance from Q1 to the median is less than the distance from the median to Q3. So it looks like this one may be the best answer choice. In other words, it's going to be skewed to the right. So again, like this, where the tail is on the right. If I go back and look at the other answer choices, D is a pretty close one. Again, there could be some debate there that, you know, these values are close to each other, but all of these statistics here are relatively small anyway. And when I say relatively small, I mean like relative to the summary statistics for depth. So the differences are going to be smaller. So let's stick with choice B.